Good evening, sir. Good evening, everyone.
Good evening, sir.
So, good evening, all of you. In this, we had started with electricity in physics. Today, we'll continue with electricity. बैठने वाला है, बैठने वाला. So, in electricity, we had done electric potential. Can anyone define electric potential again?
Sir, it is the work done by the moving object.
Yes, work done in carrying a unit charge from infinity to a point. What is potential difference?
Amount of the amount of the work done by in moving a charge from point A to point B in the electric field.
Yes, the potential difference between the 2 points A and B is the amount of work done in moving a charge from point A to point B is called as electric potential. So why electric potential is important? The reason is that electric potential decides the direction of flow of charges. You can assume that the electric potential, it is the quantity which creates a force on the charges. Okay. So electric potential creates a force on the charges and it decides in which direction will the charge flow. Okay. So the direction of charge flow is decided by the electric potential. Okay. So in what direction do the charges flow? In what direction do the charges flow? Yeah, in which direction do the charges flow?
Towards the higher potential.
In which direction? See,
From positive to negative.
from positive to negative or from a higher potential to a lower potential. So we had defined here electric potential difference. The electric potential difference, it is the amount of work done in moving a unit charge between 2 points in an electric field. Okay. So whatever is the amount of work done in moving a charge from one point to another in an electric field, that work done per unit charge is equal to the electric potential difference between the 2 points. So yesterday we considered it something like this. Suppose initially you have a charge here. Let's say you have a charge plus Q. So everywhere around it, you can experience its presence. Okay. So you can experience that yes, there is a charge. So if you try to bring about a charge from any point towards this point, it will experience of repulsion. Okay. So we tried here, yesterday we tried to bring another charge from a point A to another point B. We have like this, let this be our point A, or not A. So this is the location of the charge Q. Here it's the plus Q charge which is located here. And here we have the charge, this is point A, this is point B, where we had the test charge Q naught. A positive test charge is kept here. If we bring this charge from point B to the point A, so in this process we are doing some work. So our work done from point B to the point A will be equal to the electric potential difference between the points, and it will be equal to potential at A minus the potential at B. Okay. So work done per unit charge, work done divided by charge will be equal to the electric potential difference between the 2 points, which is also written as V BA. That means electric potential between B and A is equal to work done from B to A per unit charge. So this is the formula we studied yesterday. And from this, today we will try to define 1 volt. Okay. So let us try to define what is 1 volt. So 1 volt is the potential difference when 1 joule of work is done in moving a unit positive charge. Points. So if 1 joule of work is done in moving a charge of 1 coulomb, or you can say unit positive charge. So unit positive charge means 1 coulomb. Okay. So then the amount of potential difference between the 2 points will be said to be 1 volt. Like suppose we try to carry this charge from point A to point B. So during this process, if suppose I took here 1 coulomb of charge and I moved this 1 coulomb of charge from point B to point A. So the amount of work that I have done, that work done will be equal to the electric potential. Okay. Or you can say, if I am doing 1 joule of work in moving the charge of 1 coulomb from point B to point A, the potential difference between the points A and B will be equal to 1 volt. Understood, everyone?
Yes, sir.
Okay. So what will be the, see, the SI unit? SI unit for potential difference is volt. Okay. SI unit is volt, and it is also equivalent to joule per coulomb. So either you call it joule per coulomb or volt, which is the same. Yesterday we did one more thing. We did about the charges, that the quantity of charge Q is given as Ne, where N represents the number of electrons and E represents the charge on an electron. So here we have E equals to B. So charge on an electron is equal to 1.6 times 10 to the power minus 19 coulomb. Now today we start with electric current. So electric current, it is the rate of flow of charges per unit time. So you can consider it how fast the charges are flowing in a unit time. It is called as electric current. So as current means anything which is flowing, anything which is moving. Like we can call water current, air current. Water current is the movement of water, how fast water is moving. That we call as the water current. How fast air is moving, that we call as air current. Okay. In the same way, you have electric current. So electric current, it is the rate of flow of charges per unit time. Now, charges can flow only through those substances which have free electrons or which are conductors. So movement of charges movement of charges occur in conductors. Why does the movement of charges occur in conductors only? Why not in insulators? Yes, why does the movement of charges occur only in conductors and not in insulators? See, the insulators, they have free electrons. Insulators, conductors have free electrons. Free electrons means the electrons which are not bonded. Okay, so conductors have free electrons which move when electric potential is applied. So, Ionija, Ionija, Dhairya.
Yes, sir. Yes, sir.
Okay, why do the
Sir,
insulators not?
yes.
Why can't the plastic conduct electricity?
Sir, because plastic is an insulator
So why
and it
plastic
does
is?
not allow,
Yes, yes. Continue.
and insulators don't allow the current to pass through them.
So why they
Also,
don't
they
allow?
don't have,
Yeah, yeah.
sir, because they don't have free electrons.
Okay, very good. So plastic and other insulators don't have free electrons. So plastics and other insulators, they don't have free electrons and hence they cannot conduct electricity. Okay, what do you think about a salt solution? Is it a good conductor? Is the salt solution a good conductor or a poor conductor?
A good come.
Good conductor. So why it's a good conductor? Are there free electrons?
So is it due to the ion?
Yes. Salt solution, it contains ions. Ions to conduct electricity. So up to now we studied these points, that there can be current or there will be flow of charges. When can there be flow of charges? There will be flow of charges if we have these three things. We should have free electrons, or we can have ions, or so these should be there. There should be free electrons or there should be ions, so that there can be conductivity can be established. These are also called as charge carriers. Okay. So they are called as charge carriers. That means they carry the charge in an electric circuit. So sometimes the charge carriers can be electrons, sometimes the charge carriers can be ions. So for wire, the charge carriers are electrons, and for solutions, the charge carriers are the ions. Got it? Now, one more thing is required for the electric current to flow, and that is electric potential difference. It requires electric potential difference between the 2 points. Electric potential difference. So electric potential, there should be an electric potential difference between the 2 points. There should be free ions or there should be free electrons. हेलो कितना देर लगेगा कितना देर लगेगा ठीक so see here the electric current we have studied and what all things should be there that means there should be free electrons there should be an electric potential difference Abhinav what does electric potential do how does electric potential help in the movement of charges
So, charges travel from higher potential to the lower potential.
yes so can I say that the electric potential creates a force on the charges to move
We can.
yes we can surely we can लगा है बाहर है बाहर पता नहीं okay so let us see okay so what do we want our electric current to do when the charges are moving
Can you
what
answer the
previous one okay what do we want the suppose we created the electric potential suppose there is current so what do we want of course we want something to do with that electric current yes
Yes, sir.
so I'm asking here that if we are providing electric potential right if the current is flowing so we want to use that electric current right where all can we use that electric current
In powering up appliances.
Hmm?
In appliances.
In appliances okay so wherever obviously we want to use it in some or the other appliances like we want to use it so see we construct a circuit so circuit means there should be a source of the electric potential and the source of electric potential what is the source of electric potential what are the sources that can be used to generate electric potential sumuk sumuk
yes sir
so what is the source of the electric potential
so charge
no okay from where can we obtain electric potential
from electricity
from
electricity
electricity
voltages
voltages so how do we obtain from where do we obtain that
electric charge
no anyone of course electric charge is the fundamental for electrical energy so what are the sources available with us for electric potential See, the sources that we have. Aryan, can you think of the sources that we have for electric potential?
Can battery provide us?
Yeah, we have a battery. We
Cells.
can use a cell. We can use a battery. Any other source? Any other source that we have?
Sir, potato if like
Potato? No. See, we have cell. We can use a cell. We can use a battery, or we have an electric generator. That's a dynamo. So these are the sources of electric potential. The electric generator, you have two types. Either it can generate a DC current or it can generate an AC current. Okay. Whereas a cell and a battery, they are the sources only for DC current. So in your next chapter, we'll be discussing about DC current and AC current. Okay. DC current is also called as the direct current. So we'll be discussing this, what is DC current and what is AC current, right? So DC current, it is obtained from the sources like cell and battery, whereas electric current, electric generator, it can generate both types. It can either generate a DC or AC also. Okay. AC means alternating current, the current that we use at our home. The current that we use at our home, that is an AC current or alternating current. The current supplied at our home, that is AC current. Understood this?
Yes, sir.
Yes?
Yes, sir.
Now see how an electric device works. So an electric device works something like this. You have a wire which supplies electric charges or electric current. Then here you have your device, and that there will be a key or a switch in it. So you have a switch, and then you have a source of electric potential. It may be a cell. So here I am making a cell, and in this way your circuit is complete. So any electric circuit, it will work only when the circuit is complete. So your different components listed here. This is our switch. Yeah, this one is cell with the positive terminal and negative terminal. Here you have device, whatever electric device you are going to use. Okay. So this is a simple circuit, which how it should look like. So you have a cell, a device, a switch to control this device, like when it should be on and when it should be off. So that is controlled by the switch. Okay. Understood this? Okay. Now electrical measurements. Let us see how we make electric measurements. So electric measurements. Electric measurements, they include the measurement of current and voltage. There are different other things also which are measured, but for you currently we will be measuring the electric current flowing in the circuit, and will measure the electric voltage or electric potential between the 2 points. So See the devices that we use here. First of all, we will see an ammeter. Okay, so see, an ammeter is a device which measures electric current. You can say an ammeter. It is a device for measuring electric current. So see how an ammeter looks like. It has two terminals which can be connected with the battery or with the to the circuit. So let's say here electric measurements, that is ammeter. So all these devices which you see, they are all ammeters. So this one is also the ammeter. See. Okay, what are the units of current measured here? In this ammeter, can anyone tell what are the units in which the current is measured? See, I'm giving you these devices. This is one of the device. Here I spot another ammeter, this one. See, another ammeter is given. You see. What is the difference between these two ammeters? Just 1 minute, 1 minute. I'm giving you some more ammeters. You will be reading them. Just give me 1 minute. So see how we are going to read the current from these devices. Some others, yeah, yeah. Okay, so let's see how much we have understood and how can we measure the currents. So now all of you be active. Aryan.
Sir.
Okay, so Aryan, if you can see this ammeter. So
Yes,
what
sir.
are the units in which it measures the current?
Sir,
This ammeter which I have selected here.
microampere.
Microampere, very good. What are the units in which the second one measures? The bottom one?
Milliampere.
Milliampere, very good. So the two ammeters, they measure their currents as microampere and milliampere. Got it? Now we will try. Okay, what is the least count in each of them? Least count means what is the measurement of each division? In the second one, what will one division measure? How much current will be
10.
measured by one division? Yes,
10.
10 milliampere. Okay, so this we also call as the least count. So here for this bottom one, I observed its least count to be equal to 10 milliampere. What is the least count for this one?
5, sir. No.
Is
5,
it
sir.
5?
Sir, 5, sir.
Okay. It seems to be 5 and the picture is not clear. Okay, so we will not touch that. You can see this one. So in this one, we have to measure the current. So see how can we measure the current here? Okay, so in this one, how much current is measured by one division? Shubhansh?
0.2.
No, check it once more. How much current will be measured by each division?
Sir, 10.
Hmm?
10.
How can it measure 10? I'm asking for this one, the bigger one, where its reading is marked. This one.
Sir, 0.03. 0.3.
No, it's not
Sir,
0.3. Yes.
sir, you are asking where the red marker is, right? Or
Yeah,
the
yeah.
least
This.
count.
See, I'm not asking the current measured. I am asking you what will be the measurement of each division here.
0.02.
Yeah, each division here, it measures 0.02, right?
Sir,
So
I
here,
said the same thing, sir.
no, you said 0.2, where least count is 0.02. Okay, so I think you said 0.2.
Yes, sir.
Yes. So least count, see, there are 10 divisions between 0 and 0.2. So its least count will be 0.02, which is obtained by dividing this 0.2 by 10. That means between 0 and 0.2, there are 10 divisions. Got it? Now, we'll see what does each division measure. It's 0.02. We count down the number of divisions. So number of divisions here is 10, 12, 14, 15. Am I correct? That there it's on the 15th division. Okay. So current that it will measure will be equal to 0.02 multiply 15, which is equal to 0.30 ampere. Siddhisri, have you understood how did we find out the amount of current measured by this ammeter?
No, sir.
Have you understood?
No, sir. I did not understand.
Okay, first we find out the least count. Least count means the measurement made by the single division. What measurement will be made by each single division? Okay. Okay, you can try to measure the measurement of the second one. I think it's also the same thing. Okay. So bye all of you. We'll see you again in next class.
Bye,
Thank
sir.
you, sir. Bye, sir.
Bye.